Right, for this question, first we begin by writing the equation as follows: 6 power 6 as a negative 729, and well, this is actually negative 3 to the power 6, and so this is very cool because now we can write z power 6 3 power 6. Now of course this is actually equivalent to negative 1. You see there's a negative 1 here, and I could write this as z to the power 3 over 3 to the power 6. And well, negative 1 is actually 6 pi plus 2k pi. And so now by taking the 6th root, I will have 6 pi plus 2k pi to the power 1 over 6, and here we'll take of course k from 0 to 5. So any 5 consecutive integers will work well because you actually have 6 solutions. And using De Moivre theorem, we get 6 pi over 6 plus k pi over 3. Now of course then if I multiply across by 3, then I get 3. So these 6 solutions, and so what we do is that we can list this out when k equals 0, z0, I call it z0, is equivalent to 3 6 pi over 6, as you can see, because when k is 0, and now I go on, k equals to 1, I get z1, so it'll be 3 6. If I let k be 1, I will get 3 pi over 6. Of course that would be 3 6 pi over 2, and then go on and repeat this again and again, and we will be able to list out all 6 solutions. Here we have 5 pi over 6 and z3 when k equals to 3, 7 pi over 6, 3 pi over 2, and the last one 3 6 11 pi over 6. And so if we want to then illustrate this right here, so let it get this going. An Argand diagram, that will be your imaginary axis, the real axis. We have a different color, and we know all the solutions, they all lie on 3 units from the center. And so we sketch them now. Here's the z0, z1 is here, z2 is right here, z3, z4, and z5. And let me do this, get a segment so you can see yeah, so that's it. And you will notice that these two are conjugates, same as for these two, and these two here also. Now to do the part B, well, here we need to do make an educated guess, is that to show z squared plus 9 is a factor. Now we think that now the z squared plus 9, this expression contains no z term. This implies that the if I take 2 factors or 2 roots from here and use them to form this quadratic factor, and the SOR, the sum of roots, would be 0. So look clearly, these two, the z1 and z4, they are very special because they both lie on this the imaginary axis. So I suppose that this taking z1 and z4 would be a good choice. So so here first we list z1. Z1 is actually 3i if you think about it, and z4 is negative 3i. So you can perform getting the SOR and POR here 0 clearly, and the POR, this product of roots with this product of these two, then you get negative 9i squared, which means this is I, or rather a 9. And so we have shown that then we need to first write down, state the factor. This factor, which is formed by these two roots, is a factor of z power 6 plus 729. Right. Now next, hence they ask us to find all zeros of pz, and we try to guess it. Okay, so this pz is a quadratic expression, and here we have a quadratic, and this is power 6. So we suppose that maybe this power 6 is the factor consists of this z squared plus 9, and the remaining factor or the quadratic factor is this one. So what we want to do now is that we show that that z power 6 plus 729 can be factored into the product of this and this pz. And if we successfully can do that successfully, well, we'll know the zeros to pz. So here goes. Here we let z power 6 plus 729 be equivalent to, of course, we know that this we've shown that in B this is in fact a factor. So we know the remaining factor is a quadratic. This is power 6, this is square, so this has to be power 4. This is 729, here's 9, so the constant for this factor has to be 81. 81 times 9 is 729. And so what in between we do not know, but never mind, we just write, say that az cubed, bz squared, and I don't know, say cz. Okay, now if you compare the z term, left right side, the left side clearly is 0 because there's no any z term until z power 5 terms, and none of those. And so the z term here, we start with the z square, impossible to get z term. And the 9, now 9 if you times cz, so we get 9c. We're comparing the coefficients, so clearly c is 0, but that's nice. Then the z square term, now the z square term is also 0 for this the left hand side, and this z square here is 81. Here we get this, and for 9, if we times bz square, yeah, we'll get the z square term. So 9b. This is just nice because now we show that b is -9. And lastly, the z cubed term is also 0, the left side, and here z cubed z square, I leave times cz, so it will be c plus, and this is 9 and 9 and a, 9a. Well, because we know that c is 0, therefore a has to be 0. So we have it. Yeah, we have z power 6 plus 729 as a product of the factor z squared plus 9, and this one power 4 minus 9 z squared plus 81. So this quadratic expression is pz, and since z, you see, z squared plus 9 was formed by using z1 and z4, so whatever remains, the z0, 2, 3 and 5, they must be then the zeros for this particular expression. So hence clearly, right, zeros of pz are, of course, z0, z2, z3 and z5. So that's it. Hope you do the other questions, and all the best.